Hello there, and welcome to Forgotten Worlds, where curiosity takes its shoes off, the lights dim, and questions that might feel too big for the daytime can drift in softly. My name is Thomas, and tonight I'd like to invite you into one of those questions. A question that begins not with a bang, not with a warning, but with a quiet absence. Imagine waking tomorrow night and looking up at the sky. The stars are scattered in their usual constellations. The Milky Way stretches faintly overhead, but something is missing. The moon, that familiar silver companion, is simply not there. No crescent rising in the west. No pale glow washing over rooftops or fields. No tide clock pulling gently at the sea. Only darkness, sharper, deeper, unfamiliar. For as long as there have been eyes to look upward, the moon has been there. It has kept time, guided harvests, inspired myths, pulled oceans, and steadied the very tilt of our seasons. Its light has been painted into poetry, its cycles written into calendars, its gravity woven into the rhythms of every shoreline on Earth. And so the question comes, if it vanished tomorrow, would our world collapse into chaos, or would it find some quieter, stranger balance? This is not a story of prediction or prophecy. It is a thought experiment, a slow wandering through science, imagination, and wonder. We'll move from the physics of the impossible to the first nights without moonlight, from the reshaping of tides to the trembling of seasons, from the songs of animals that lose their lunar cues to the myths humanity might weave in its absence. But before we go further, let's take a moment together. Wherever you are, perhaps you can picture the moon as it was last night, or the last time you paused to notice it. Its pale disk glowing above trees or city streets, its reflection stretched across a bay, its slow, patient climb. Hold that image for a moment, because in the world we're imagining tonight, it is gone. So settle in, breathe gently, and let's drift into the question, what if the moon vanished tomorrow? Of course, the moon cannot simply wink out of existence. Matter does not vanish like a candle flame blown in the wind. And yet, for the sake of imagination, let us wander into the impossible. If tomorrow brought a sky without the moon, how could such a thing have happened? What cosmic hand could have reached into the sky and removed it? One possibility is impact. A colossal strike by a wandering body, a rogue asteroid, or even a planet-sized intruder shattering the moon into fragments. We know such violence is possible because it has already happened in our solar system. The scars are written across the surfaces of every world we've studied. Mercury, battered into a pitted husk. Mars, with its northern lowlands gouged by ancient impacts. Even Earth bears its wounds, craters softened by erosion, oceans filling the scars of long-forgotten collisions. And the moon itself is a library of impact history, each crater a chapter, some so immense they span entire lunar basins. A strike big enough to erase the moon would be beyond anything life on Earth has yet endured. The debris alone could rain down with apocalyptic fury, boiling oceans, darkening skies. To destroy the moon and leave Earth untouched is perhaps the least likely scenario of all. Another path might be escape. Gravity is a dance, and though the moon has circled Earth for billions of years, in theory it could be flung away. A passing giant, a rogue planet drifting through the solar system might tug it loose, stealing it into a new orbit or casting it into the cold dark between stars. The odds are infinitesimal, but the cosmos does not shy away from improbabilities. There are worlds adrift in the void, lonely planets wandering without suns, their histories carved by chance encounters. If the moon were swept away, it would become one more traveler, a pale ghost moving silently through interstellar night. And then there are stranger imaginings. A black hole, small and hidden, passing through our neighborhood of space. To us it would be invisible, a shadow with mass, bending light and swallowing matter. If it brushed close enough, the moon might fall inward and vanish completely. No fragments, no collision, just absence. In a way, this is the cleanest removal of all, not an explosion, not a theft, but a quiet swallowing. The moon's substance compressed into invisibility. Each of these scenarios asks for unimaginable energy. To obliterate the moon would require a strike equal to the very forces that created it. To hurl it from orbit would demand the gravitational hand of a giant far larger than Earth. To erase it into a black hole would mean cosmic chance so rare we might not even have words for it. And yet, when we look at the history of the solar system, we find echoes of such enormities. Planets have been torn apart. Moons have been captured, flung away, or melted into fragments. Saturn's rings, delicate and luminous, may themselves be the remains of a moon that wandered too close and was shredded by gravity. The asteroid belt between Mars and Jupiter is a broken remnant of collisions that never formed a planet. Even the moon, we know our moon, was likely born of destruction when a world the size of Mars struck Earth and left behind the glowing debris of its aftermath. So the impossible is not entirely impossible. The sky has always been shaped by catastrophe. If the moon vanished tomorrow, we would know that somewhere, somehow, another of those cosmic chapters had been written. Then let us imagine that chapter beginning not in fire or fragments, but in silence. One evening the moon is there, serene and familiar, and by the following night it is gone. No warning, no trail of debris across the heavens, only an absence where for billions of years a presence has been. The first consequence would not be visible in the sky, but in the oceans. The moon's pull on Earth is constant, steady, always lifting a bulge of water toward it. With that gravity suddenly removed, the seas would respond at once. Tides that had risen 2 meters the night before might climb only half as high. Beaches that had been rhythmically drowned and revealed for untold generations would suddenly find themselves oddly still, their twice-daily flooding reduced to the weaker tug of the sun. Within hours, coastal marshes would be left dry, their grasses exposed. Estuaries, which pulse with life precisely because they breathe with the tides, would feel the change immediately. The ocean's heartbeat, long paced by the moon, would falter, and above, the night itself would change. We do not always notice how much light the moon lends to our world until it is gone. A full moon is bright enough to cast shadows, to illuminate fields and rivers, to guide night travelers and hunters alike. Without it, the darkness would be complete, the stars sharper, yes, but the land far dimmer. Nocturnal animals that time, their foraging by lunar brightness would be thrown into confusion. Small mammals that avoid predatory moonlight would find every night safe. Owls and foxes might find fewer prey venturing out. Sea turtles, who climb ashore guided by the moon's glow, would be left without a compass. The entire choreography of the night would falter. And then there is us, humanity, so long accustomed to glancing upward and seeing that silver lantern. Imagine the psychological jolt of its absence. For millennia, the moon has been a constant, the companion of lovers, the subject of poets, the measure of months. Its absence would not simply be astronomical, it would be intimate. People would step outside their homes, lift their eyes, and feel a chill that is not entirely from the night air. Something familiar has been stolen. Something permanent has proved fragile. The first days would be filled with questions and unease. Children would ask why the moon is gone, and adults would have no ready answer. News anchors would speak in measured tones, but their words would circle the same unanswerable truth. The sky has changed. And though the earth itself might still turn, still orbit the sun as before, the rhythm of nights and tides would already feel altered, as though the world itself had skipped a beat. The oceans, more than anything else, would be the first to reveal how deeply we have always lived in the moon's embrace. To stand at a shoreline is to watch gravity made visible, to see with your own eyes the pull of another world. Twice each day, without fail, the waters gather themselves and rise, pressed forward by an invisible hand. Twice each day they retreat, uncovering sand and stone, mudflats and reefs, as though breathing with a rhythm older than memory. This rhythm belongs to the moon. Its gravity reaches across the void and raises a bulge in Earth's oceans, pulling water toward it on the near side, and, by the strange laws of orbital mechanics, lifting another bulge on the far side as well. Earth rotates beneath these bulges, and so our coastlines feel the tide come and go, a slow, rolling inhale and exhale. The numbers are simple, but the consequences are vast. Without the moon, the tides would shrink to less than half their current height. The sun, distant though enormous, also pulls on our oceans, but its effect is weaker. Where the moon dominates, the sun can only assist or soften. When sun and moon align at new moon or full moon, their pulls add together, producing the higher spring tides, which can lift waters several meters in some bays. When they are at right angles, first quarter or last quarter, their pulls interfere, and the tides are gentler, known as neap tides. It is this dance, month after month, that keeps our coasts alive with change. If the moon were removed, only the sun's hand would remain, and the difference would be profound. Picture a fishing village where the spring tide climbs nearly 2 meters, flooding into the salt marshes, filling tidal creeks, and retreating again to reveal glistening mudflats. In a world without the moon, that same tide might rise only a single meter. The water would not reach as far inland. The creeks would be shallow, the marshes left drier, the mudflats exposed longer. The daily landscape itself would alter. Children who once played at the tide line would notice it no longer swept so high against the rocks. Boats that relied on tidal lift to float free from shore might find themselves stranded. What once felt like a living pulse would now feel muted, quieter, almost subdued. And the difference is not just local. The moon organizes the oceans on a planetary scale. Its gravitational grip helps mix water between the surface and the deep, driving circulation patterns that distribute heat and nutrients. Without that extra stirring, the great conveyor belts of the sea might slow. Imagine the ocean as a vast cauldron. The sun provides heat, the wind stirs the surface, but the moon's pull tilts the pot, ensuring the mix reaches into every corner. Remove it, and layers might separate. Warm water sitting atop cold, nutrient-rich depths, fertility locked away where life cannot reach it. It is strange to think how something so far above us dictates the very shape of our shorelines. Walk along a beach and notice where the rocks are smoothed, where barnacles cling, where driftwood piles. Each of these is a signature of tidal range. Some shores are sculpted daily by the rush and retreat, others gently lapped. But everywhere, the moon's invisible fingers are at work, sanding edges, feeding estuaries, carving tidal pools that host entire microcosms of life. If tomorrow those fingers let go, the reshaping would begin instantly. Within days, wetlands would dry earlier, currents would run weaker, sediment would settle differently. Within years, the geography of coasts would begin to drift from what we once knew. And yet, standing there, you might not see catastrophe. The tide would still come and go. Waves would still break. The sun would still pull its gentler rhythm. To the casual eye, perhaps nothing disastrous would appear. But beneath that apparent normalcy, the balance would be unraveling. To grasp the magnitude of change, imagine your own breath. If each inhale were halved in depth, you would still survive, still draw air, still live, but the rhythm would no longer sustain you in quite the same way. The moon's absence does that to the ocean, a breath shortened, a pulse weakened, enough to alter everything that depends on it. And what a vast everything that is. Nearly 3/4 of humanity lives within 50 kilometers of a coast. Billions rely on the sea for food, transport, identity. Entire cultures mark time not just by the moon's phase, but by the tide's height. In some fishing communities, children learn before they can read how to read the beach, how to know when the tide will carry fish close, when the sandbars will appear. To those eyes, the loss of lunar tides would not be subtle. It would be immediate, unsettling, a fracture in tradition and survival. Even inland, far from the salt smell of shore, the moon's role is hidden in the flow of rivers. Tides reach upstream, lifting and lowering water levels that affect navigation, flooding patterns, even the cycling of nutrients carried down from the land. Farmers in estuarine valleys might suddenly notice their soils drying differently, their crops thirstier. It would feel as though something beneath the ground had shifted, when in truth it is something above the sky that is gone. There is a peculiar humility in realizing that our greatest planetary tides do not belong to Earth alone, but to a relationship, a gravitational duet between planet and moon. Without the moon, Earth would still sing, but the harmony would be thinner, the melody simpler. The vast crescendos of spring tide would vanish, leaving only quieter notes. And perhaps that is the strangest truth of all, that the moon, silent and cold, barren of air or life, is nonetheless the maker of Earth's music. Not in sound, but in movement, in the ceaseless rising and falling of seas. If it vanished, we would not only lose a companion in the sky, we would lose the rhythm of our oceans, the measure by which shores have breathed since before there were human eyes to watch them. So let us pause for a moment, right here at the edge of the tide. Close your eyes and picture the sea. Picture the waves lapping higher, then retreating, then higher again. Picture the line of wet sand marking the reach of the last high tide. And then picture it lower only half as far, the foam not quite reaching your toes. It looks almost the same, and yet it isn't. That small difference cascades outward, reshaping coasts, starving ecosystems, silencing rhythms. That is the power of the moon. That is what we risk when it is gone. Then let us step beyond the shoreline, into the living world that depends on those tides. For though the ocean may look only slightly changed, life notices in ways far sharper than we do. To creatures shaped by millennia of lunar rhythm, the loss of the moon is not subtle, it is upheaval. Estuaries are among the most fertile places on Earth. They are where rivers meet the sea, where fresh water mingles with salt, and where tides push inland twice a day, carrying nutrients and stirring the waters into a living soup. Salt marshes flood, mudflats glisten, mangroves breathe with the rhythm of ebb and flow. Shrimp, fish, and countless invertebrates hatch and feed in these tidal nurseries, sheltered by the pulse of the tide. Without the moon, that pulse weakens. The water no longer floods as far or as often. Shallow creeks that once brimmed with tidal life become stagnant trickles. Sediment settles and smothers instead of being carried away. Slowly, invisibly at first, the nursery dims. Juvenile fish find fewer safe spaces. Birds find fewer meals in the mud. The abundance that has always drawn life to these places begins to shrink. And then there are coral reefs, luminous underwater cities, built not by human hands but by the patient labor of polyps, tiny creatures that turn sunlight and calcium into skeletons of stone. Reefs are exquisitely tuned to the moon. Their mass spawnings, those miraculous nights when corals release billions of eggs and sperm into the water at once, are often timed to lunar cycles. On certain nights after the full moon, reefs across vast regions come alive in a synchronized bloom. It is one of nature's grandest spectacles, a planetary heartbeat keyed to moonlight. Remove the moon, and that cue vanishes. The sea may still provide warmth and currents, but the ancient clock is broken. Corals might stumble into random timing, their reproductive cycles unsynchronized, their survival uncertain. And with reefs faltering, the countless species that depend on them, fish, turtles, sharks, even the communities of people who fish and farm their waters would feel the unraveling. In the intertidal zone, the loss would be even starker. This is the realm between high and low tide, a world of extremes where barnacles, mussels, crabs, and sea stars cling and crawl in habitats alternately drowned and exposed. Here, life has evolved to a rhythm that is nothing less than lunar. At high tide, fish sweep in to feed. At low tide, shorebirds arrive. Creatures time their feeding, hiding, and reproduction to the precise schedule of the tide. With that range suddenly halved, their habitat shrinks overnight. Rock pools dry sooner, mudflats are smaller. Whole communities collapse inward, competing for space that no longer exists. And with tides weakened, nutrient cycles falter. The moon's gravity does more than pull water up and down. It stirs the ocean itself, mixing surface waters with the nutrient-rich depths. That mixing feeds plankton, which feed fish, which feed the world. With less stirring, the ocean stratifies warm waters trapped at the top, cold, rich waters locked below. Fertility sinks out of reach. Fisheries thin. The chain from plankton to whale weakens link by link. Even the shape of the land changes. For millions of years, strong tides have carved and defended shorelines, wearing down cliffs, moving sand, building and erasing beaches. With weaker tides, erosion patterns alter. Sediment builds where it once washed away. Deltas clog. Some coasts grow marshy, others retreat more quickly, as storms become the dominant sculptors. Human settlements, so often built at river mouths and harbors, would find their relationship to the sea newly unpredictable. And across this shifting world, species whose very reproduction is tied to the moon would falter. Horseshoe crabs, ancient survivors older than trees, rise from the sea to lay their eggs in sand precisely at high tide during full and new moons. Grunion, those silvery fish along the Pacific, wriggle ashore in synchrony with spring tides to spawn. Sea turtles, guided by moonlight, crawl inland to bury their eggs. Without lunar tides and cues, these species stumble in the dark. Their eggs may dry before waves can reach them, or wash away before they hatch. Entire lineages could vanish simply because the sky went dark. It is worth pausing here to notice how delicate the thread is. For billions of years, Earth and Moon have danced together, and life has braided itself into their steps. Evolution has written lunar cycles into DNA. Remove the Moon, and that script must be rewritten, not over centuries, but over days. Some creatures may adapt. Some may invent new rhythms, guided by the sun or by chance, but many will not. Extinction, slow and quiet, would follow in the wake of every tide that no longer reaches high enough. For us, the change would be measured first in empty nets, in coasts that no longer yield what they once did. The sea would look the same from a distance, but its generosity would wane. Food chains disrupted at the bottom ripple upward and eventually reach us. Billions of people, dependent on fish and shellfish, would find themselves searching farther, deeper, for sustenance that once arrived with the moon. And yet, in all this loss, there is also a strange possibility. Perhaps new life would arise to fill the gaps. Perhaps without lunar tides, creatures would adapt to solar tides, to currents driven by wind, or to cycles of temperature and storm. Evolution has a way of improvising. What seems like an end to us may be only a transition to something unforeseen. A new order of the sea, written not by the moon but by Earth alone. Still, that would be far in the future. In the first centuries of a moonless Earth, what we would notice most is absence. The silence of marshes where birds no longer feed, the emptiness of reefs that no longer bloom in synchrony, the stillness of beaches where tides no longer carve their daily lines. The ocean would still breathe, but shallowly. Life would still move, but less abundantly. The sea, once a place of pulsing rhythm, would seem subdued. So imagine yourself once more at the shore, but this time not as a casual visitor. Imagine you are a fisherman, your family's livelihood tied to nets and tides. You rise before dawn as generations have, expecting the sea to deliver what it always has. But the tide is lower, the fish are fewer, the marsh is quiet. You look up at the sky for reassurance, for the moon that has always been there. And the sky offers only darkness. This is what it means to live in a low-tide world. Then let us turn our gaze upward once more, not to the tides at our feet, but to the tilt of the world beneath them. For the moon does more than pull at oceans. It steadies the very axis on which Earth spins. Without it, even the length of a season, the rhythm of a year, the balance of heat and cold, would tremble. Right now, Earth leans. Its axis is tilted about 23.5 degrees relative to its orbit around the Sun, and that tilt is the reason we have seasons. Summer comes when our hemisphere leans toward the Sun, winter when it leans away. Spring and autumn are the gentle transitions between. We take this tilt for granted, as if it were a permanent setting. A knob turned once at the beginning of time and left untouched. But in truth, it is the moon that keeps the knob steady. Earth is not a rigid, unyielding sphere. It wobbles. Like a spinning top, our planet is subject to precession, the slow drift of its axis. Alone, Earth's tilt would swing wildly over time, tugged by the gravitational pulls of the Sun, Jupiter, and other planets. But the moon, with its relatively large mass and close orbit, acts as a stabilizer. Its gravity tugs on Earth's equatorial bulge, damping the wobble, anchoring the tilt within a narrow band. For billions of years, this has been our quiet protection, a satellite that prevents Earth from swaying too far into chaos. Without the moon, this balance would unravel. Over millennia, Earth's axis could swing anywhere from near upright to almost horizontal. Imagine summers where the sun never sets for half the year, followed by winters of endless night. Imagine ice caps sprawling across continents, then retreating in sudden bursts of heat. Seasons would no longer be gentle, predictable rhythms. They would be brutal, chaotic, perhaps unlivable in many regions. To understand this fragility, we need only look at our neighbors. Mars, with no large moon to steady it, tilts erratically. Its axis has wandered from near 0 degrees to over 60 degrees in its history, flipping its climate from polar ice ages to equatorial glaciers. Uranus is tilted so far it essentially rolls on its side, its poles baking for decades of summer before plunging into decades of winter. These are the faces of planets without stabilizers. Earth's tilt stability is not only about surface climate. It is tied to the deep interior as well. The moon's tidal pull affects not just the oceans, but the mantle and even the liquid outer core. As Earth turns, the moon's tug creates tidal friction, subtly stirring the molten layers within. This interaction is thought to help regulate the geodynamo that generates our magnetic field, the invisible shield that protects us from solar, wind, and cosmic radiation. Without the moon, tidal friction diminishes. Over long spans of time, that could mean changes to the core's flow, perhaps even weakening the field that shelters us. It is humbling to realize that the tilt of our world, the seasons we paint into calendars and festivals, the very shield that guards life from the sun's fury, are all linked to the moon's patient pull. We think of the moon as distant, pale, quiet, but in truth it is an anchor sunk deep into Earth's stability. Remove it, and the planet begins to sway, to wobble, to stagger like a spinning top nearing the end of its motion. Pause for a moment and think about the seasons as you know them. The long, bright days of summer, the chill of winter mornings, the blossoming of spring. Each one depends on a tilt that has remained within a narrow, stable range for billions of years. Each one depends on the moon. Without it, summer might mean searing heat that scorches crops to dust. Winter might mean sheets of ice that never melt. Spring and autumn might vanish altogether, replaced by sudden, violent shifts. This is not a change we would notice overnight. In the first years after the moon's disappearance, the tilt would remain as it is, the seasons carrying on. But slowly, over thousands, then millions of years, the drift would grow. Civilizations might rise and fall before the wobble became unbearable. Yet the seeds of instability would already be planted, hidden in the silent absence of a satellite we once thought ornamental. The moon, then, is not an ornament. It is a gyroscope, a counterweight, a guardian. And without it, Earth would be less like the steady cradle we know and more like a ship adrift in stormy seas, its mast swaying unpredictably, its course uncertain. So when you next feel the warmth of summer or the bite of winter, remember, you are feeling the moon's gift. A tilt held steady, a rhythm kept true, a balance that, without its silent hand, might have long ago collapsed into chaos. Without the moon's steadying hand, Earth would become a planet of moods, shifting from one extreme to another over spans of thousands, even millions, of years. The tilt of our axis, now a stable 23.5 degrees, could swing like a pendulum, drifting through ranges as gentle as 10 degrees or as catastrophic as 85. Such swings are not idle speculation. Computer models of orbital mechanics suggest that without lunar stabilization, the gravitational nudges from Jupiter and other planets would amplify Earth's natural wobble, sending the axis into wide and unpredictable arcs. Picture it. At a tilt of just 10 degrees, our seasons would soften. Winters would be mild, summers subdued, the equator spreading warmth more evenly across the globe. Crops might flourish in higher latitudes, while polar ice caps would expand more gently. But at the other extreme, a tilt of 80 or more degrees, the planet would be nearly sideways, with poles facing the sun directly for months at a time. In such a world, one hemisphere could bake in endless summer while the other lay buried in perpetual night and ice. Oceans might boil in the heat of one pole while glaciers swallowed continents on the other. Life would retreat to the narrow equatorial band, struggling to find balance in the thin strip between extremes. Earth, then, would not have seasons as we know them. It would have epochs of seasons. For thousands of years, a region might enjoy stability, only for the axis to drift and rewrite the climate. Civilizations could rise in fertile lands, flourish for centuries, and then collapse as the tilt swung and their world turned uninhabitable. Agriculture, dependent on predictable cycles, would falter in the face of such erratic shifts. Human history, if it even persisted, would be a series of migrations, always chasing the temperate zones, always fleeing the creeping cold or scorching heat. We can find echoes of this instability by looking at Mars. With no large moon to steady it, Mars's axial tilt has wandered wildly, swinging between nearly upright and more than 60 degrees. When its tilt is high, the poles receive more sunlight, ice caps shrink, and frozen carbon dioxide sublimates into the atmosphere, thickening it for a time. When the tilt is low, the poles sink into deep freeze, the atmosphere thins, and vast glaciers spread. Evidence in Martian geology shows shifting ice deposits, migrating glaciers, and layers of sediment that record these swings like rings in a tree. Mars is, in effect, a warning of what Earth might become without the moon. A world where climate is not background but destiny, reshaped again and again by a restless axis. On a moonless Earth, such cycles would ripple across every part of the biosphere. Animal migrations, tied to seasonal cues, would unravel. Plant life, adapted to stable zones of sunlight and rainfall, would wither or shift, entire forests migrating across continents over millennia. Ice ages might last longer, pressing sheets of ice deep into mid-latitudes. Then, suddenly, the tilt might reverse, plunging icy lands into heat and melting glaciers into catastrophic floods. The weather, too, would grow chaotic. Jet streams that now trace steady paths around the globe would warp and wander as the distribution of sunlight shifted. Storms might rage with new ferocity, carrying tropical rains into regions once dry, or freezing winds into regions once warm. The delicate belts of climate equatorial tropics, temperate mid-latitudes, polar caps would dissolve into a shifting patchwork. And yet, life is stubborn. In such a wobbling Earth, new strategies would emerge. Creatures might evolve greater mobility, able to migrate vast distances in pursuit of habitable conditions. Plants might develop dormant phases, seeds waiting centuries for favorable climates to return. Humanity, if it endured, would perhaps build societies less tied to place and more to movement, cultures of travelers, always watching the sky not for the moon, but for the angle of the sun, the telltale measure of how far the axis had tilted. It is a strange thought that the difference between stability and chaos lies in a pale rock 400,000 kilometers away. But this is the moon's legacy. It has kept Earth's mast upright, its seasons steady, its climate stable enough for civilization to take root. Without it, we would live not on a cradle, but on a ship tossed endlessly by invisible currents, always uncertain where the next storm would strike. So the next time you feel the predictability of seasons, the sure return of spring blossoms, the certainty of autumn leaves, remember that they are not guaranteed. They are a gift of balance, held in place by the quiet gravity of the moon. And if that balance were lost, Earth would become a planet of restless tilts, a world always on the edge of extremes. Then, let us follow this thought further into the slow drift of climate itself. If the moon were no longer here to steady Earth's tilt, the axis would begin to wander, and with it, the climate would cease to be a reliable companion. Seasons would remain, but not as we know them. They would stretch, break, and tilt into states unfamiliar, sometimes for centuries, sometimes for millennia. Climate would become less a backdrop to life and more the central actor, rewriting the script of the world again and again. To imagine this, we can turn to models that scientists have built, simulating what happens when Earth's tilt is left to the whims of gravity alone. These models show a planet veering between states, sometimes tilted only a little, basking in gentler seasons, and other times nearly sideways, with one pole staring directly at the sun. Each state rewrites the global distribution of light and warmth, shifting the balance of heat across continents and oceans. At shallow tilts, perhaps only 10 or 15 degrees, the equator would spread its warmth more evenly. Polar regions would grow colder, their ice sheets thickening, creeping further south or north. The seas would withdraw into frozen vaults, lowering global sea levels, chilling the planet into something like an ice age. Wind belts would tighten, driving cold, dry air into places once temperate. Forests would wither into tundra. Humanity, if present in such an epoch, would cluster in the shrinking belts of arable land. At steep tilts, perhaps 60 or 70 degrees, the effect would be opposite and more violent. One hemisphere would face the sun continuously for months, its surface roasting under unrelenting daylight. Glaciers would collapse, seas would rise, air would fill with water vapor itself, a greenhouse gas amplifying the heat. Meanwhile, the opposite hemisphere would lie in months-long night, plunging into deep cold. When the sun returned, the ice would melt in sudden floods, reshaping coasts and river valleys. The planet would lurch between fire and ice, neither state lasting long enough for life to adapt. Ocean currents, too, would be reshaped by these shifts. Today, The Gulf Stream and other great conveyors carry heat around the world, moderating climates, bringing warmth to Europe, rains to the tropics. They are driven in part by differences in temperature and salinity gradients the moon helps maintain through its stirring tides. Remove the moon, destabilize the tilt, and these currents could stall or even reverse. A world without the Gulf Stream, for instance, would leave Europe in icy winters even as the tropics sweltered. Whole continents would feel climates that no longer matched their geography. The winds would follow suit. Jet streams, those high-altitude rivers of air that guide storms, are sensitive to temperature contrasts between equator and poles. As the tilt wandered, so too would those contrasts. Sometimes the streams would snake wildly, dragging Arctic air into deserts and tropical rains into tundra. Other times they might flatten, leaving regions locked in drought or flood for decades. Weather would lose its balance, becoming a mirror of the axis itself, unpredictable, restless, unstable. And in this chaos lurk tipping points, thresholds beyond which the planet does not return easily. If ice sheets grew too vast during a shallow tilt, their white surfaces could reflect so much sunlight that Earth would lock into a permanent snowball state. Oceans frozen from pole to equator. If, during a steep tilt, greenhouse gases rose too high, the planet might tip into a runaway warming, oceans evaporating into skies that trapped ever more heat. Both have happened before. Geological records show Earth once locked in global ice, and at other times searingly hot, with palm trees in the Arctic. Without the moon, such states might become not rare catastrophes, but recurring patterns. For humans, the implications are profound. Imagine building a city in a fertile valley, only to find that within a few generations the axis has drifted and the rains have stopped, the valley turning to desert. Or imagine a civilization rising on a coastline, flourishing for centuries, and then watching the sea surge inland as ice sheets collapse under a new tilt. Migration would become perpetual, cultures in motion not because of war or ambition, but because the planet itself refused to stay still. And yet, even as we trace these shifts, it is important to remember the timescale. These tilts and drifts unfold over thousands, sometimes millions of years. To an individual human life, the climate might still feel slow, seasons still recognizable. But over generations, the change would be unmistakable, written in oral histories and myths, tales of lands once fertile, now barren, of seas once frozen, now warm. The moon's absence would be remembered not only in the darkened sky, but in the stories people told of a world that could no longer be trusted to stay the same. In this way, climate drift without balance is not merely a scientific forecast, it is a philosophical one. It reminds us that the stability we take for granted, the gentle predictability of spring following winter, of rain feeding rivers, of crops sprouting where they always have, is not inevitable. It is the gift of a silent guardian, one that hangs above us night after night. Remove it, and the Earth itself becomes a different kind of planet, a place of uncertainty, where the climate is not a backdrop but an ever-shifting stage. So the next time you feel a breeze in summer or see frost on winter grass, know that you are experiencing not just Earth's tilt, but the moon's steadying hand. And imagine, for just a moment, what it would mean to live without that hand. To live on a world where the winds never settle, the seas never rest, and the seasons drift like a dream, always on the verge of turning into something else. If we wish to glimpse what a moonless Earth might become, we need only look backward into our own planet's deep history. For there were times, long before human eyes could watch the sky, when Earth's climate lurched into extremes so strange and violent that life itself nearly perished. These episodes are our analogues, our warnings, reminders that balance has always been fragile and that without the moon, such fragility would only deepen. The The most haunting of these episodes is known as Snowball Earth. Geological evidence tells us that more than 600 million years ago, glaciers spread from the poles all the way to the equator. Imagine standing at the shore of the tropics, not under palm trees, but at the edge of a frozen ocean. Ice sheets kilometers thick sealed the seas, reflecting sunlight back into space, locking the planet into a deep freeze that may have lasted millions of years. Volcanoes still erupted beneath the ice, but their heat was swallowed. Oceans beneath the crust of ice may have harbored life, but the surface was silent, white, and still. How did Earth escape? Slowly, carbon dioxide from volcanoes built in the atmosphere, greenhouse gases trapping what little heat the sun provided. Eventually, the planet thawed, swinging from one extreme to the other, ice giving way to flood, glaciers melting into roaring seas. Life survived, but altered. Complex multicellular organisms arose soon after, perhaps shaped by the crucible of that frozen world. Now imagine such events in a moonless Earth. Without lunar stabilization, axial wobbles could trigger snowball-like states again and again. A shallow tilt could cool the poles until ice crept downward. Albedo, the reflectivity of snow and ice, reinforcing the freeze until even equatorial seas were trapped. And without the moon's steadying influence, such frozen epochs might recur far more often, trapping life in cycles of near extinction, testing resilience with every tilt. On the opposite end of the spectrum lies another warning: the Paleocene-Eocene thermal maximum, about 56 million years ago. In this episode, global temperatures spiked by at least 5 to 8 degrees Celsius in just a few thousand years. The cause is debated. Perhaps massive volcanic eruptions released carbon. Perhaps frozen methane hydrates burst from the seafloor, but the effect was unmistakable. Forests grew in the Arctic. Tropical creatures spread poleward. Oceans acidified, leaving shells thin and fragile. Rainforests expanded, deserts shifted, and mammals underwent bursts of evolution to survive the heat. It is sobering to realize how quickly this transformation unfolded. A few thousand years, a blink in geological time, and Earth became a furnace. Now place such a furnace into the context of an unstable tilt. Without the moon, extreme tilts could amplify these heating events. A pole facing the sun might roast under perpetual daylight, while methane release or volcanic carbon tipped the balance into runaway warming. Regions that are now temperate breadbaskets could become deserts within the lifetime of a civilization. Oceans could rise by tens of meters, swallowing coastlines before cultures had time to retreat. The lesson of both Snowball Earth and the Paleocene-Eocene thermal maximum is clear. Earth has always been capable of violent swings. With the moon, these events are rare, separated by millions of years. Without it, the wobbles of our axis could bring them more frequently, perhaps even rhythmically. A frozen epoch here, a greenhouse epoch there, alternating like a planetary pendulum. And in such a world, where could life endure? Some regions might become refuges. Equatorial belts during ice ages could remain warm enough for forests and seas to persist. Mountain valleys during greenhouse epochs might offer cooler havens. Humans, if they survived, would become wanderers of climate zones, always seeking the narrow bands where life still flourished. Cities might be temporary, built with the knowledge that the axis could shift, the climate could collapse, and migration would soon follow. Other regions would be abandoned, continents locked in ice for thousands of years, deserts spreading until nothing grew, islands swallowed by seas rising meter after meter as glaciers melted. The map of habitable Earth would redraw itself again and again, its borders no longer fixed by geography, but by the wandering balance of tilt and sun. The question is not whether life could survive. Life is resilient beyond measure. The question is whether our life, our civilization, could survive such relentless change. We are creatures of habit, of agriculture rooted in place, of calendars built on predictable seasons. Remove that predictability, and we are unmoored. We would live always on the edge of disaster, in a world where climate was no longer a steady background, but a restless tide. So, when we look at Earth's past, we do not just see ancient catastrophes. We see previews. We see what happens when balance is lost, when ice locks the planet or heat scalds it. With the moon, such events are rare enough that life has time to recover, to flourish in between. Without it, the rhythm quickens, the catastrophes multiply, and the story of Earth becomes not one of stability, but of endless upheaval. And perhaps the greatest tragedy is that the night sky, silent and dark without its silver companion, would give no hint of the chaos below. The moon would be gone, the guardian vanished, and the Earth left to write a new kind of story, one where every tilt of its axis could redraw the meaning of home. The moon's departure would not only unsettle Earth's climate and tilt, it would strike at the beating heart of marine ecosystems. Life in the oceans has been synchronized for millions of years with the rhythm of lunar tides. From the quiet mass spawning of corals to the sudden frenzy of fish and crabs racing to the surf, the moon's pull is a cosmic metronome, keeping time for creatures that do not wear watches but still live by the clockwork of the sea. Without this gravitational guide, an entire orchestra of marine behaviors would lose its conductor. Take, for instance, the sea turtle. For millennia, female turtles have emerged from the surf under the cover of night, often timing their nesting with higher tides to carry them closer to the dune line. The moon does more than light their way. It dictates the rhythm of waves that smooth and soften beaches, shaping the very landscapes where their eggs are laid. With tides diminished to half their height, those protective washes of water would fall short, leaving nests further exposed to predators and desiccation. Hatchlings, too, rely on lunar light reflecting on the sea's horizon to guide them towards safety. Without the moon, the newborns would stumble in greater numbers inland, chasing artificial lights or starlit illusions, and perish before ever touching the surf. Or consider the California grunion, a fish whose reproductive ritual is among nature's most dramatic spectacles. Only during the very highest spring tides, when the moon's gravity lifts the sea to its peak, do grunion ride the waves ashore in shimmering schools. Females wriggle into wet sand, deposit eggs, and vanish before the next breaker, while males coil around them in a silver dance. The moon is written into their DNA, encoded as both stage and signal. Without it, the spring tides would shrink, their breeding stage erased. A species evolved to live on the razor's edge of lunar timing would suddenly find itself cast adrift, its spawning grounds high and dry. Horseshoe crabs, ancient mariners from a lineage older than the dinosaurs, are another example. Every spring, at the full and new moons, they swarm beaches by the thousands to mate and lay eggs in synchrony. Shorebirds migrating from as far as the Arctic depend on this feast of crab eggs to fuel their journeys. Without the moon's gravitational cue, the swarms would falter. Spawning might scatter across days and weeks, weakening the critical pulse of food that sustains not only crabs but entire chains of life that rise and fall with them. The collapse would not stop at the shoreline. It would ripple into the skies, starving birds, reducing populations, and breaking links in a web of survival that spans continents. Coral reefs tell a quieter but equally devastating story. Across the Great Barrier Reef and other tropical seas, entire colonies release their eggs and sperm in synchronized clouds, triggered by a blend of water temperature, daylight length, and, crucially, the rising moon. This synchronization ensures that millions of gametes flood the water at once, overwhelming predators and maximizing fertilization. Without the moon, corals would lose their signal. Spawning events would fragment, mistimed, and fail more often. Fertilization rates would plummet. Reefs, already under siege from warming and acidification, would face a reproductive silence that could push them past the brink. Even creatures not directly nesting on shorelines feel the moon's loss. Countless invertebrates, worms, mollusks, crabs time their life cycles with tidal flooding. Their larvae drift into estuaries at just the right moment, carried by lunar-pulled surges. Shrimp burrow and emerge in step with the tide. Barnacles expose themselves, then retreat. Remove the moon, and the tide shrinks. The windows of opportunity narrow, and the intricate choreography of intertidal life falters. Species that cannot adapt quickly enough would vanish. The scale of loss is staggering. Entire food webs are stitched together by these moon-driven pulses. Predators follow prey that follows the tide. Shorebirds, fish, marine mammals all depend on a rhythm that would suddenly fall still. Intertidal zones, where biodiversity explodes in every crevice and tide pool, would become graveyards of stranded organisms or barren mudflats. And unlike climate, which shifts over centuries, this disruption would be immediate. The very next spawning season, Grunion would find no tides high enough to bear them ashore. The next generation of sea turtles would hatch under a sky too dark and beaches too dry. Horseshoe crabs would scatter their eggs in futility. Within years, some species would crash. Within decades, entire ecosystems might unravel. Humans, too, would feel the consequences. Fisheries that rely on predictable spawning runs would collapse. Coastal communities that harvest crabs, clams, and fish keyed to lunar tides would lose not just food, but livelihoods. What seems like a subtle shift, tides reduced by half, becomes catastrophic when amplified through the fragile dependencies of life. The moon has been more than a silent guardian in the sky. It has been a partner in life's design. Its disappearance would not just alter the seas. It would cut the threads of continuity that countless species depend on, silencing rituals older than humanity itself. In a moonless world, the sea would no longer sing its familiar song of rise and fall. It would whisper only half its rhythm, and for many forms of life, that silence would mean extinction. The moon has been more than a silent guardian in the sky. It has been a partner in life's design. Its disappearance would not just alter the seas. It would cut the threads of continuity that countless species depend on, silencing rituals older than humanity itself. In a moonless world, the sea would no longer sing its familiar song of rise and fall. It would whisper only half its rhythm, and for many forms of life, that silence would mean extinction. And yet, extinction is only half of nature's story. For as long as there has been life, there has also been change. When rhythms falter, life seeks out new ones. Creatures that once looked to the moon would search for subtler clocks, guided not by a vanished companion in the sky, but by the remaining patterns of the earth and sun. Over generations, evolution would experiment with new ways of keeping time. The tides, though weaker, would still exist, pulled gently by the sun. And in those softer pulses, some species might find a way forward. The fish that once swarmed beaches in shimmering tides might give way to others, less tied to lunar exactness, more attuned to the daily warmth of the sun or the steady pull of equinox and solstice. Worms, mollusks, and crabs that once danced to the precise beat of spring tides might retreat permanently to deeper water, or else grow hardier, able to endure long stretches of exposure without the ocean's timely return. In time, Earth's shores could come alive with entirely new kinds of amphibious beings, occupying the silence left by those that vanished. The changes would not stop at the shoreline. On land, the darkness itself would become a new kind of stage. For countless generations, nights have been divided between moonlit and moonless, a cycle of brightness that governs the risks and opportunities of the night. Small mammals often venture out only when the sky is dark, hiding from predators in the brightness of the full moon. Without that division, every night would be the same, darker, deeper, less forgiving. Rodents would scurry more freely, no longer forced to balance hunger with the glow of exposure. Predators, in turn, would adapt. Owls and foxes, deprived of moonlight's silver assistance, would hone their other senses. Sight might sharpen in the dark, ears might grow larger, keener, whiskers more sensitive to the subtlest vibrations. Migrating birds, too, would be cast adrift. Many species take cues from the moon as they chart their long seasonal journeys across continents and oceans. With that beacon gone, some migrations would falter, with flocks scattering or falling short. Yet others might adapt by leaning more heavily on the stars, reading constellations with greater precision, or by tuning into the faint compass of Earth's magnetic field. In this way, the moon's absence could make stellar navigation more central to life than ever before, and still stranger changes might unfold. In the deeper dark, new sources of light could evolve. Fireflies already pulse in fields and forests with their quiet sparks. In the oceans, countless creatures bloom with bioluminescence, casting their own glow where the sun cannot reach. Without the moon, perhaps such gifts would spread. Mammals with faint luminescent markings to signal mates. Flowers that glimmer faintly at night to guide pollinators. Meadows and forests that, over millennia, might glow with subtle, living constellations of their own. Eyes, too, would change. Some species might grow larger, more attuned to every scrap of starlight. Others might begin to see wavelengths hidden from us, now infrared, ultraviolet, building new ways of perceiving the world in the absence of the moon's glow. Echolocation, now the gift of bats and dolphins, might spread into entirely new families of animals, reshaping the soundscape of the night. The air itself would become alive with voices pitched beyond our hearing, creatures drawing maps of the world with sound instead of sight. Even humans would not be untouched. Over thousands of years, in societies without artificial light, darker nights might favor sharper eyes, keener ears, greater night vision. Myths would change too. Where once we spoke of silver moons and moonlit paths, we might speak of glowing flowers, luminous creatures, stars brighter than memory. Folklore would no longer look upward for its inspiration, but downward, into a night remade by evolution's quiet hand. The moon's absence would not end life's rhythms, it would transform them. The old patterns, written across billions of years, would vanish. New ones would take their place, stranger and perhaps more fragile, but alive nonetheless. For life, as always, would find a way to sing, even in the deepest dark. For humanity, though, the moon's disappearance would carry not only ecological but also cultural silence. We forget, sometimes, that our sense of time itself was first taught to us by the sky. Before we had clocks, before we divided the day into hours or mapped the year into numbered calendars, we watched the moon. Its cycle of waxing and waning gave early humans their first reliable measure of passing days, a rhythm longer than the day but shorter than the year. In the curve of its crescent and the fullness of its disk, they saw a clock that belonged to everyone, everywhere, uniting hunters and farmers, priests and sailors beneath a common cycle. Remove the moon, and that ancient clock is broken. The months themselves, once moon months, lose their anchor. For the Islamic calendar, built entirely on the lunar cycle, the very structure of time would vanish overnight. Festivals, fasts, pilgrimages, all of them depend on the sighting of a new crescent. Without it, centuries of tradition would be forced to shift onto solar reckoning or into some artificial imitation. The Mayan civilization, had it arisen in a moonless sky, could never have woven its intricate calendar of lunar phases and solar years. The Chinese calendar, the Hebrew calendar, countless other systems born from lunar observation, would have no foundation. And think of the farmers who once looked to the moon to guide the sowing and harvest. For thousands of years, Agricultural almanacs advised planting by the waxing moon, harvesting by the waning. Perhaps some of these instructions were superstition, but they carried with them the comfort of continuity. A farmer could stand beneath the night sky, glance upward, and know what to do tomorrow. Without that silver reminder, humanity would have been forced far earlier into artificial systems of time, perhaps precise, perhaps efficient, but stripped of the intimacy of sky watching. Even our language bears the moon's imprint. The very word month is its child. Words for time in countless tongues still trace back to lunar cycles. Remove the moon, and those linguistic echoes would never have been born. Our very speech would carry fewer reminders of the heavens. It is hard to imagine how differently human history might have unfolded without lunar timekeeping. Would agriculture have developed more slowly, deprived of its nightly guide? Would rituals of renewal and festivals of light, tied to phases of the moon, have ever existed? Would navigation across deserts and seas have been attempted so boldly, without the crescent and full moon to serve as a companion? These are questions without answers, but they remind us how deeply the moon's rhythm has entered our own. And now, imagine the shock of losing that rhythm in the present day. Even though we live in an age of atomic clocks and satellites, of calendars that stretch centuries into the future, the disappearance of the moon would still tear at something older in us. Nights without a crescent would feel strangely unmarked, lacking the gentle reminder that time is passing. Months would feel less alive, reduced to numbers without the phases that once gave them character. Festivals would be disoriented, their sacred timings lost. Religions that have looked upward for millennia would find the sky suddenly silent. Time itself would feel different. The years would still turn, the earth would still orbit the sun, but the subtle division of nights into waxing and waning would be gone. Humanity, for the first time since its birth, would live under a sky without a clock. And while our machines could still measure time with precision, they could not replace the comfort of glancing upward and seeing it written in light. The moon has always been more than a lamp. It has been our first teacher of cycles, of patience, of return. To lose it is not just to lose a companion in the sky, but to lose part of the story of how we came to know time itself. And yet, the loss of the moon would not only alter how we measure time, it would reach inward into the quiet chambers of human life, reshaping the way we sleep, dream, travel, and even feel at home in the universe. For the moon is not just a clock or a calendar, it is a presence, a light that has kept humanity company through every night of its history. Take it away, and the world after dusk would become a different place altogether. Imagine stepping outside on what would once have been a full moon night. Now there would be only darkness. Stars would burn more sharply overhead, yes, but the earth below would be swallowed. The familiar path to a neighbor's door, once visible in pale radiance, would vanish. Forests would become walls of shadow. Even the ocean, which once glittered under moonlight, would appear as a black expanse, its waves audible but unseen. For countless generations, people have walked, hunted, and celebrated under that pale light. Moonlight guided shepherds tending flocks at night, soldiers marching silently across fields, explorers steering ships into unknown waters. Before torches and lanterns were common, before electricity painted the night with artificial glow, the moon was civilization's lantern. Its cycles determined when armies would move, when caravans would cross deserts, when lovers would meet in secret, when villages would hold festivals long into the night. In its absence, the night would feel heavier, more confining. A darkness without contrast, without relief. Sleep itself might change. Human circadian rhythms are not governed solely by the sun, they are nudged by the presence of lunar light. Studies even today suggest that people sleep less and dream more vividly around the full moon, though they may not notice it. For thousands of years, families and communities may have unconsciously adjusted their activity to these cycles, more wakeful and energetic in moonlit nights. quieter in darker ones. Take away the moon, and every night becomes equally dark, equally deep. Sleep might lengthen perhaps, or dream patterns might shift. But something subtler would be lost. The sense of variation, the ebb and flow of energy across a month. And beyond sleep lies psychology. The moon is a familiar face in the sky, a constant reminder that the heavens are not empty. Its phases are visible even to a child, its light a comfort to travelers, its presence a steadying companion to anyone who has ever looked upward in solitude. Imagine the first generation to grow up without it. Children would ask why the sky was missing something. Poets and artists, long inspired by its glow, would have to turn their attention elsewhere. The cultural imagination would contract. The night sky would feel larger, colder, lonelier. Navigation, too, would suffer. For as long as there have been journeys across sea and sand, the moon has been a guide. Mariners once used its phases to predict tides, to chart calendars, to keep steady time while crossing oceans. Desert travelers moved at night, using moonlight to see without exhausting themselves in the heat of day. Even in war, moonlight was both ally and enemy, bright enough to reveal movements, dark enough at times to conceal them. Whole strategies turned upon its cycle. Without the moon, history itself might have unfolded differently. Battles delayed, migrations slowed, discoveries postponed. And what of the mind, deprived not only of light, but of companionship? The moon has been a mirror for human longing, a symbol of romance, of mystery, of divine presence. Myths and religions have poured into it, deities housed there, lovers exiled, dreams projected. Without it, our stories would change, but perhaps they would also thin. The night would offer fewer metaphors, fewer images of comfort, for a world without the moon is not just a darker world, but a less human one. One can picture it, a future person, centuries after the moon's vanishing, walking beneath a sky unlit, unbroken, only stars above. They pause, searching instinctively for the disk their ancestors once saw, the pale shape that waxed and waned, marking time and lending comfort. But they find nothing. And though they might marvel at the brilliance of the Milky Way, they will feel a subtle emptiness, a missing note in the music of the night. For the moon was never only stone and dust, it was a companion. And without it, humanity must learn to live in a world that feels, in some quiet way, incomplete. The night sky, stripped of the moon, would become both richer and poorer, a paradox etched across the stars. For on the one hand, a darkness more complete than any our species has known would settle over the earth. On the other, that very darkness would reveal wonders long hidden, as though the heavens themselves had been waiting behind a veil for this moment of unveiling. Imagine looking upward without that familiar silver face. The moon has always been the brightest object of the night, a constant presence so luminous it drowns fainter stars and washes the Milky Way from view. Remove it, and the night sharpens. Galaxies spill into visibility. Faint clusters glow where once they were invisible, and the arch of the Milky Way burns with a brilliance not seen since before the first campfires. Astronomers and dreamers alike would find themselves beneath a sky so rich it might overwhelm them, yet it would be a richness haunted by absence. For the very lack of the moon would be written into every glittering star, like silence lingering behind music. Practical life would shift as well. For countless generations, the moon has been a lantern for travelers. Caravans crossing deserts, sailors guiding ships through uncharted seas, villagers moving across fields at night all once relied on its glow. Its absence would make night journeys harder, more perilous. Stars can guide, but they do not light the path. A shepherd leading sheep across a plain would stumble more often. A sailor would find the sea darker, the line between wave and sky erased. Where once the moon gave both direction and comfort, the heavens would now feel vast but indifferent. And then there are the eclipses. Few spectacles have so captured human awe as the moments when sun and moon meet. A solar eclipse, with its brief, terrifying darkness, and a lunar eclipse, when Earth's shadow stains the moon red. These events have shaped myths and calendars alike. Without the moon, they vanish entirely. The sky loses not only a companion, but a drama, a recurring reminder of the celestial clockwork we inhabit. Children in a moonless world would grow up never knowing the sudden chill of an eclipse, never seeing the stars blaze at midday as the sun disappears behind a darkened disk. That whole theater of shadow and light would be erased. And what of the constellations? The moon has always wandered among them, passing through zodiac signs, brushing past bright stars, aligning with planets. It is the night's moving actor, while the stars remain a fixed stage. Without it, the constellations would seem oddly static. No silver guest would visit them, no bright intruder would slide across their patterns. The heavens would be frozen in place, beautiful but still, lacking the living motion that once animated them. Astronomers would gain a clearer sky. Yes, the moon's glare often blinds sensitive instruments and makes faint objects impossible to study. A darker sky would sharpen every telescope, both in observatories and in the backyard. Whole catalogues of faint galaxies, nebulas, and comets would expand, their details finally revealed. For the scientist, it would be a gift. But even in that gift, there would be a shadow, for the moon was also a laboratory of its own, a nearby world whose craters told the story of impacts and collisions across the solar system. Its absence would make the sky clearer but poorer in context, sharper but emptier of meaning. And beyond science lies something harder to name. The moon is more than a guide or a spectacle, it is a rhythm. Its phases mark not only calendars but moods. A waxing moon carries a sense of rising energy, a waning moon, a sense of closure. Artists and lovers have looked up and felt kinship with its changes. Without it, the night would lack those familiar gestures, those reminders that even the heavens pass through cycles of birth, fullness, and decline. The stars, brilliant as they are, do not change in ways we can watch with the naked eye. They do not mirror our own sense of passing time. The moon did. So the night sky without the moon would be both dazzling and desolate. The stars would sing louder, but the harmony would be thinner. The constellations would shine, but the dancer who once passed among them would be gone. Humanity would inherit a sky that was deeper, clearer, more eternal, but also lonelier. The moon has been humanity's great rehearsal stage for the cosmos. Long before we dreamed of starships or Martian colonies, we learned to step off our world by setting foot on that familiar neighbor. It was close enough to reach in days, safe enough to attempt, and rich enough to teach us lessons about both Earth and space. Without the moon, this first step would have been denied us. Consider the Apollo program. Every rocket test, every mission, every photograph of Earth rising above a grey horizon was a training exercise in leaving home. The moon was not just a destination, it was a laboratory of survival. We learned how to operate machines in vacuum, how to shield astronauts from radiation, how to navigate in space without air or weather. Without this halfway house, humanity's first leap into the solar system might have been too far, too dangerous, too unimaginable. Mars, 100 times more distant than the moon, is not the kind of first step a cautious species takes. The moon also gave us samples, dust and stone older than any earthly mountain. These rocks told us of the early solar system, of violent impacts and fiery oceans of magma, of the collision that may have birthed the moon itself. Without them, our understanding of planetary history would have been dimmer. Earth's own crust is restless, constantly recycled by plate tectonics. Only on the moon did we find the preserved scars of the ancient bombardment that shaped all planets. Without that record, would we even know how dangerous space could be? Impact cratering, for instance, was first understood on the moon. For centuries, scientists argued whether its pits were volcanoes or collisions. It was only by comparing lunar craters with those on Earth and realizing they shared a common origin that we began to grasp that worlds are shaped by impacts. Without the Moon as a canvas, perhaps we would never have recognized the threat of asteroids in time to prepare. Perhaps our sense of the solar system as a dynamic, sometimes hostile place would have come centuries later. Even geology itself was changed by lunar science. The Moon showed us what happens when a world has no air, no water, no plate tectonics. Its surface becomes a frozen archive of impacts, lava flows, and cosmic dust. Without that comparison, Earth's geology might have seemed complete in itself. We might never have understood how special our restless, living planet really is. And then there is the speculative but profound question: would we ever have reached the planets at all without the Moon as our first destination? The Moon was not only a stepping stone but a motivator. Its glowing face hung over every civilization, challenging us to reach it. Presidents promised it, nations raced for it, poets imagined it, engineers built for it. Without that nearby target so visible, so attainable, perhaps humanity's ambition would have faltered. Mars might have seemed too far, too costly, too uncertain. Robotic probes might still have gone, but would humans have dared? Would we have risked lives for a red dot in the sky, with no nearer practice ground? It is possible that space exploration itself would have been stunted. Satellites might still circle Earth, telescopes might still peer outward, but the dream of leaving our world could have remained abstract. The Moon's absence might have left us with a sky full of stars but no ladder to climb toward them. The irony is sharp. The Moon is both a fragment of violent chance, a byproduct of a colossal collision, and a carefully placed bridge, enabling a fragile species to practice before it ventures far. Without it, we might still be looking up, wondering, but never stepping out. The Moon is not just a companion in the sky, it is a regulator of time itself. Through the mechanism of tidal friction, it has been gradually slowing Earth's rotation for billions of years. Here's how it works. As the Earth spins, the oceans bulge slightly toward the Moon. But because Earth rotates faster than the Moon orbits, those tidal bulges don't point directly at the Moon. They are carried slightly ahead. This displacement creates a gravitational tug that drags on the Moon, nudging it farther away, while simultaneously pulling back on Earth's spin, slowing it down. The result is a cosmic exchange of energy. The Moon drifts outward by about 3.8 centimeters per year, roughly the speed. Fingernails grow while Earth's days lengthen by about 1.7 milliseconds per century. In deep time, this has had dramatic effects. Fossil records of ancient corals and tidal deposits reveal that 400 million years ago, a day lasted just 22 hours. Go further back, and 1.4 billion years ago, Earth spun so quickly that a day was only 18 hours long. Without the Moon, this gradual slowing would come to a halt. Earth's rotation would stabilize at roughly 24 hours, the length we experience today. On the surface, that might seem like a minor difference after all. We already live by a 24-hour rhythm. But the implications run deeper. In the immediate term, very little would change in our daily experience of time. The sun would still rise and set on a familiar schedule. But the long-term trajectory of planetary motion would be disrupted. With no lunar pull, Earth would no longer be part of the slow, graceful spiral toward tidal locking with the Moon, a process that would eventually have stretched days to nearly 47 hours before the sun swelled into a red giant and erased both worlds. Instead, time on Earth would be frozen, locked in its present cycle, a planet spinning at nearly the same pace forever. Yet stability here is not entirely a blessing. The Moon's drag on Earth has acted like a governor on a machine, smoothing the rhythms of planetary motion and preventing chaotic oscillations between resonant states of Earth's orbit and spin. Without it, Earth's rotation could interact differently with the sun's pull and the shifting arrangement of continents. Oceanic and atmospheric tides would become less complex, changing how angular momentum is exchanged between Earth's crust, oceans, and atmosphere. Some models suggest this could eventually lead to subtle but persistent instabilities, periodic fluctuations in rotation rate that might alter climate cycles on scales of tens of thousands of years. Thus, while a moonless Earth would keep its 24-hour day, the underlying stability of time itself, the long-term rhythm of spin, orbit, and seasons would be weaker. What seems fixed could, over epochs, become a little more fragile. And once again, we see that the moon is not just scenery. It is a regulator, a silent hand keeping the metronome of Earth's rotation steady across the ages. Thus, while a moonless Earth would keep its 24-hour day, the underlying stability of time itself, the long-term rhythm of spin, orbit, and seasons would be weaker. What seems fixed could, over epochs, become a little more fragile, and once again we see that the moon is not just scenery. It is a regulator, a silent hand keeping the metronome of Earth's rotation steady across the ages. But when a metronome falters, the orchestra it guides begins to drift. And Earth's orchestra is not only the sky above, but the very rocks beneath our feet, the restless oceans, the slow breathing of glaciers, and the tectonic plates that carry the continents. Without the moon's steadying pull, the planet's geological rhythms would be nudged into a different and more unpredictable pattern, one where cascades of change echo from sea to stone. The oceans would be the first to feel it. We have already imagined how tides shrink in a moonless world, but their loss reverberates in another way, by altering ocean currents. Today, tides help stir the waters of the deep, mixing nutrients and keeping heat circulating. Without them, that circulation would weaken. Combined with a wobbling axial tilt, currents would fall under the stronger influence of wind alone. Monsoons might grow erratic. El Niño and La Niña cycles could deepen into longer, harsher swings. The conveyor belts that now move warm water northward and cold water southward could falter, leading to abrupt freezes in one hemisphere while the other broils. This redistribution of heat would, in turn, reshape the ice caps. Greenland and Antarctica, sensitive to even subtle changes in climate, would experience cycles of growth and collapse far beyond what we know today. Imagine ice sheets surging outward, scouring bedrock, then retreating violently, sending armadas of icebergs into the sea. Sea levels would lurch up and down over millennia, flooding coasts and then bearing them again. Without the moon's stabilizing influence, Earth's cryosphere, the icy crown that reflects sunlight and cools the planet, would become another unstable player in a chaotic climate symphony. And yet the cascade does not stop at the surface. Glacial cycles and shifting seas alter the weight of water and ice pressing down on continents. When ice builds, it pushes land downward. When it melts, the land rebounds. This flexing of Earth's crust is more than cosmetic. It affects fault lines, volcanic systems, and even the circulation of magma deep below. In a moonless Earth, where tilt-driven climate swings would be amplified, the rhythm of loading and unloading would intensify. Earthquakes might come in new pulses. Volcanoes could surge in bursts as mantle plumes respond to the easing of weight above. Even plate tectonics, the slow drift of continents, might find itself nudged into new tempos by the chaotic forcing of ice and ocean. Over millions of years, these patterns could write a different geology than the one we know. Picture coastlines more jagged, carved by relentless cycles of sea advance and retreat. Picture mountain chains rising not just from steady collisions of plates but from punctuated bursts of uplift as ice sheets melt and continents rebound. Imagine volcanic provinces waxing and waning in sync with the great swings of Earth's tilt, painting the land with lava in unpredictable intervals. speculation allows us to stretch further. Perhaps in such a world, Earth would develop what geologists might one day call chaos stratigraphy, layers of rock recording not steady climate epochs but erratic, rapid alternations. Sediments would show bands of Ice Age debris pressed close against layers of tropical coral, a geological palimpsest of climates turning on a planetary coin toss. In the deep past, Earth has written such stories during episodes of snowball Earth and sudden warming. But without the moon, such transitions might become the rule rather than the exception. In this way, the moon's absence is not just a subtraction from the sky, it is a subtraction from the ground beneath us. The crust itself would grow restless, oceans would wander, glaciers would advance and retreat like tides of stone, and the geological memory of Earth would become a book written in hurried, uneven strokes. Over spans of millions of years, our planet would look less like the stable cradle of civilization and more like a stage of recurring upheavals, its surface forever adjusting to the absence of that distant, steadying hand. Civilization is a fragile arrangement, more delicate than the stone it builds with, or the cities it raises. It rests on a narrow balance of climate, fertile soil, predictable rains, and seas that both feed and restrain. Remove the moon, and the threads of that balance begin to fray. The geological cascades that reshape Earth's crust ripple outward into the fabric of human survival, bending agriculture, fishing, and settlement into precarious shapes that may not endure. Agriculture would be the first to feel the tremors. Fields depend not only on soil but on the rhythm of the seasons. A wobbling earth, lurching between steeper tilts and shallower ones, would deliver summers of blistering heat followed by winters of crushing cold, or long periods where spring never quite arrives at all. Crops adapted to narrow temperature windows would fail. In regions where monsoons feed rice paddies, rains might vanish for decades or pour down in destructive torrents. Farmers, who for 10,000 years have looked to the sky with confidence in its cycles, would find themselves at the mercy of a sky that no longer repeats. The coasts, once fertile edges of civilization, would fare no better. Human life has always clustered along shorelines, where rivers meet seas, where estuaries teem with life, where tides renew the fertility of the shallows. Without the moon, those tides diminish, shrinking to weak solar pulses. Estuaries would stagnate. Nutrients that once flushed in and out would settle into still waters, breeding dead zones. Coral reefs, already sensitive to change, would wither. The fisheries that sustained countless cultures, from Polynesian voyagers to Nordic cod fleets, would collapse into silence. Humanity would not starve all at once, but the safety net of the sea would be cut, leaving societies more brittle in the face of famine. History offers warnings, small mirrors of what might unfold. The Akkadian Empire in Mesopotamia, among the first great states, collapsed around 2200 BCE after a sudden drought that withered crops and emptied canals. The Maya civilization faltered through cycles of drought and social stress. Even the Norse settlers of Greenland abandoned their colonies when a minor cooling of climate, now called the Little Ice Age, strangled their farms and fisheries. In each case, climate shifted only a little, yet societies cracked under the pressure. Without the moon, such pressures would come not as exceptions but as recurring rules. Imagine future civilizations clinging to fertile corridors while deserts expand, moving capitals as coastlines drown and retreat, watching grain belts migrate northward or vanish entirely. Technology might buffer the blows: irrigation, greenhouses, engineered crops, but even advanced tools can only stretch resources so far when the foundation itself is unstable. Civilizations might become nomadic again, not in caravans but in entire migrating nations, following shifting climates like herds on a planetary scale. Others might retreat into fortified zones of relative stability, leaving vast tracts of Earth abandoned to storm and ice. And beneath it all lies a haunting symmetry. the moon, which once steadied the earth enough for agriculture to arise, for cities to flourish, for calendars to be written, would in its absence erase much of what it enabled. The first farmers once sowed seeds by the light of a waxing moon. Without it, the last farmers may harvest under skies, unmarked, uncertain when rains will come, unsure if their land will last another season. Adaptation has always been humanity's strongest instrument. Fire against the cold, boats against the sea, cities against the wilderness. We have never been content to yield entirely to the forces around us. And so, if the moon were gone, if tides weakened and seasons wobbled, we would almost certainly try to answer with invention. Yet the scale of the loss would force us to ask a question older than civilization itself. Do we bend with the Earth's new rhythms, or do we attempt to impose new rhythms of our own? Some visions lean toward engineering solutions, monumental in ambition. Artificial tide generators, vast underwater turbines, or lunar replacement satellites might be built to stir the oceans, to simulate the mixing once done effortlessly by the moon's pull. Engineers might imagine orbital mirrors deployed to steady sunlight across erratic seasons, reflecting warmth onto frozen farmlands or shading overheated plains. A civilization that can launch thousands of satellites could, in theory, weave a net around its world, a technological stand-in for the guardian it lost. Yet technology carries costs. Machines break, resources thin, and systems depend on stability to function. In a world of shifting climates and failing coasts, maintaining such colossal projects would demand unity, discipline, and faith in institutions that might themselves be strained by scarcity. Even now, with the moon above, humanity struggles to act as one against climate challenges of its own making. Would we manage better against forces beyond our control? Or would our efforts fragment, some regions turning inward, others gambling on desperate schemes that falter with time? There is also the philosophical question of resilience versus fragility. Perhaps the path forward would not lie in grand constructions but in humility. To accept a moonless Earth might mean relearning older patterns of living flexibility, migration, diversity of crops, ways of life less tethered to narrow bands of predictability. Civilizations might scatter into smaller, adaptive units, more like ecosystems themselves than towering empires. Resilience, in this sense, would not be a matter of conquering chaos, but of learning to dance with it. History whispers both lessons. Empires that sought to dominate the environment, rigid irrigation systems, monocultures stretched across vast plains often shattered when climate shifted. But smaller, more adaptive cultures sometimes endured, adjusting, surviving, carrying memory into the next age. In a moonless future, both strategies would likely play out again. Some societies would stake everything on technology's ability to replace the moon. Others would shrink, adapt, bend like reeds before the storm. And in this struggle lies a deeper reflection. The moon has always been a mirror, not only of sunlight but of ourselves. Its absence would force us to see our place more clearly. Are we a fragile species, one collapse away from silence, or are we something more, an echo of resilience, capable of surviving even when the sky itself changes? Perhaps the answer would not be singular. Some civilizations might collapse, their monuments left as silent ruins beneath erratic skies. Others might endure, smaller, stranger, more fluid, carrying forward a way of being suited to a world without a guardian. And humanity, reshaped but not erased, would continue its story, no longer guided by the moon, but by its own hard-earned rhythms. Myths are the stories we tell to place ourselves in the cosmos, and few symbols have been more enduring than the moon. Across cultures and across time, its waxing and waning became a mirror of birth and death, of fertility and famine, of gods who rose and fell as the night sky shifted. To imagine a world without the moon is not only to strip away tides and seasons, but to unweave the fabric of myth itself. Humanity would be left with an emptier sky, and with it, a need to invent new stories to fill that silence. In Greek tradition, the moon was Selene, a goddess who rode her silver chariot across the heavens. She was also Artemis, the huntress who ruled the night, and Hecate, the keeper of mysteries and crossroads. Each phase of the moon suggested another face, another mood of the divine. Without the moon, such stories would never have been told, or else they would have attached themselves to stars alone, leaving us with a mythology narrower, less layered. In Hindu cosmology, the moon is Chandra, a deity tied to timekeeping, fertility, and the balance of creation. The lunar calendar remains vital for festivals, rituals, and the measure of sacred time. A moonless sky would have forced Hinduism to bind itself more tightly to the sun, perhaps elevating solar gods to exclusive prominence. The rhythm of months, now called masas, would vanish, leaving only solar years to measure holy days. The richness of duality, sun and moon, light and reflection would have been replaced by a single, unchallenged source. In Chinese tradition, the moon is the home of Chang'e, the goddess who drank the elixir of immortality, and of the jade rabbit, who pounds medicine in a mortar beneath its glow. Mid-autumn festivals, lanterns, poems, and romances all root themselves in that luminous disk. A moonless China would still have poetry, but its imagery would be drawn only from stars and seasons. Its festivals shifted towards solstices, harvests, and perhaps the movement of planets. The jade rabbit would hop among constellations instead, a lonelier figure without its lunar home. Among indigenous traditions, the moon has countless roles. For Inuit peoples, it is Aningan, the brother who chases his sister, the sun, across the sky. For many North American tribes, the moon defines the calendar of the year: snow moon, harvest moon, wolf moon. For the Maori of New Zealand, the moon's phases guide planting and fishing. In all cases, the moon binds human livelihood to celestial rhythm. Without it, the naming of time would shift toward rains, winds, or animal migrations, building calendars less tied to the heavens and more to the earth itself. The moon's role in religious calendars cannot be overstated. The Islamic calendar is purely lunar, shaping Ramadan, Eid, and the rhythm of worship. Judaism preserves the lunar month, even within its lunisolar structure. Christianity still marks Easter by the first full moon after the equinox. A moonless world would strip these religions of their scaffolding. Sacred time would be redefined, perhaps by equinoxes alone, perhaps by planetary cycles. Rituals tied to the glow of a full moon would have no anchor. Faith itself would adapt, but its myths would grow in different soil. And then there is the speculative question: what myths would arise in a moonless world? Humanity's imagination abhors a vacuum. Perhaps the brightest planet Venus, radiant in dawn and dusk, would take the moon's place as the primary companion of the night. Myths of love, longing, and cyclical rebirth might attach to its steady glow, though it never waxes or wanes. Or perhaps the Milky Way itself, more visible without lunar light, would become the central symbol, a river of stars, a celestial road, a reminder of journeys between life and death. It is also possible that myth would turn inward. Without the moon's pale mirror, humanity might find fewer gods in the sky and more within themselves. The absence of the moon might be explained not as loss but as mystery, a sky incomplete, a cosmos with a missing piece, a myth of absence itself. Poets might write of a vanished companion, philosophers of a world designed to remind us that wholeness is never given, only sought. In such a world, the great religions and traditions would still rise, still shape meaning, still guide human hearts. But their constellations of stories would be different, leaning on stars and planets rather than the great silver lantern. Myth would adapt, as life always does, yet it would carry within it a hollow note, a silence where the moon's glow should have been. And perhaps, in that silence, humanity would always feel the tug of a story untold, the tale of a companion who never was. The moon has always been more than a rock in the sky. It has been a muse. Across centuries and continents, its pale glow inspired poets, musicians, and artists to capture something larger than themselves. Shakespeare spoke of the inconstant moon. Shelley called it a veiled lamp of night, and painters from Van Gogh to Caspar David Friedrich found in it both solace and mystery. Music has echoed its rhythms: Debussy's Clair de Lune, Beethoven's Moonlight Sonata, ancient lullabies sung under its watchful face. Remove the moon, and we remove not just a physical body, but a reservoir of human wonder. In a world where the moon never rose, art would have taken different paths. The night sky, though rich with stars, offers no single companion to focus the gaze. Without the waxing and waning arc to symbolize cycles, rebirth, and longing, imagination might have turned more toward the sun or the shifting patterns of constellations. Instead of moonlight sonatas, we might have starlight preludes. Instead of lovers walking by moonlight, poetry might linger more on the fleeting brilliance of Venus or the arc of comets. Yet there is something singular about the moon that no other light replaces. Its illumination is soft, steady, and human-scaled, not too distant like the stars, not too blinding like the sun. It casts shadows gentle enough to wander by, bright enough to stir longing. Without it, the texture of night changes. Darkness becomes more absolute. The very idea of romance, of quiet solitude under a watchful glow, would never have taken shape in quite the same way. Imagine stories stripped of the moon's imagery, the wolf howling only at stars, the lonely traveler guided only by the Milky Way. The resonance would be thinner, the metaphors harder, the tenderness dimmed. And yet, absence itself can inspire. In a moonless world, poets might craft verses about what is not there, the gap in the heavens, the silence of a missing companion. Artists might paint skies with strange, unsettling emptiness, canvases of longing for something never known. Music might echo darker themes, weaving harmonies of solitude and incompleteness. The poetry of absence is no less powerful than the poetry of presence. It simply speaks in a different register, one tinged with ache. Perhaps, too, imagination would shift from above to within. Without a glowing satellite to reflect sunlight, humanity might turn inward for reflection. Literature might lean more heavily on dreams, psychology, and memory, exploring inner landscapes in place of celestial ones. The moon has always been a mirror, not only of the sun, but of our inner selves. Without it, that mirror might be sought in other forms: water, fire, love, or silence. Still, we cannot escape the sense that something essential would be missing. The moon has been humanity's lantern, its confidant, its eternal prece once in stories of love, loss, and longing. To lose it is to lose a companion in wonder itself. For imagination needs anchors, symbols to tie the ineffable to the everyday. The moon has been that anchor for as long as we have looked upward. Without it, the human spirit would still dream, still sing, still create. But its creations would carry a shadow, the echo of a silence in the sky. And perhaps that is the final role of the moon in art, not only to illuminate, but to remind us of mystery. Its silver glow has always been both known and unknowable, a light we can measure but never quite possess. If it vanished, wonder would not vanish with it, but it would turn into something lonelier, more fragile, a song missing its refrain. Humanity would still gaze upward, still long for meaning, still find poetry in the stars. But it would always be haunted by the thought of a light that might have been. The moon has always been more than stone and shadow. It has been our balance, our tide, our compass. It steadied the Earth's tilt, pulled the seas in breathing rhythms, carved calendars in the sky, and gave poets a lantern to dream by. Its loss is not only a question of physics, but of meaning. To imagine a world without it is to imagine a different Earth entirely, an Earth of restless seasons, diminished tides, broken myths, and darker nights. And yet, in such imagining, we glimpse something deeper: how fragile balance is, how easily wonder can vanish, how much of our humanity has been shaped not by what lies beneath our feet, but by what shines above our heads. Without the moon, the Earth would go on, but it would be altered, a ship adrift without its counterweight, a story missing one of its oldest characters. We might adapt. New myths would form, new sciences emerge, new rhythms take root. Humanity has always been resilient. But even so, the loss would linger not only in ecosystems and climates, but in the quiet spaces of the heart. For the moon was not just a regulator of seas and seasons, it was a companion, a confidant, a reminder that even in darkness there is light. And so the question remains: without the moon, is Earth still Earth? Or does it become something stranger, a planet more precarious, a home less familiar? Perhaps the answer lies not in what would be lost, but in what would remain: our capacity to wonder, to dream, to look upward, even when the sky is empty. So picture this. You are standing on a darkened coast. The sea is quiet, its tides shallow, its rhythm muted. Above you, the stars blaze with unusual clarity, yet the sky feels bare, as if a note has been struck but the melody left unfinished. You wait for the moon, as all your ancestors did, but it never comes. The waves lap faintly at your feet, the air is still, and the night stretches vast and unbroken. And there, in that silence, you feel the truth. The moon is gone, the world turns on, but something essential has slipped away, and you are left beneath a sky where the moon should be, but isn't.